Hi everyone, Assalamualaikum. In this video, we will continue with example 4b for radioactive decay under application of first order ODE. The isotope 253Es and strontium-253 was used to produce mendelevium atomic number 101. 253Es decays at a rate proportional to the amount present. After 12 days, 2/3 of the isotope remains. Determine its half-life, right? Alright, first we need to extract all the information in terms of T for time and P for population, right? Alright, we check one by one here. We have after 12 days. So we can write T equals to 12 days, okay? 2/3 remain. So we can write P equals to 2/3 P naught. Okay, P naught means original P. Okay, so this is from the word 2/3 remain. Okay, so we can write this. Okay, and then determine its half-life. Okay, so we can write find T in this when P equals to half P naught. Okay, from the word half-life. Right? And then from here, the initial P is not given. Okay? So we need to write when T0, when time 0, P population equals to P naught. Right? Right, this is an initial P. Right? Right, after that, from D population over D time equals to Kp. Okay? Separating variables T and P. Okay? So we get this. Okay? From over dt here, we move to right hand side. So we get multiplication of dt. Okay? And then from times p here, we move to left hand side. So we get times 1/p. Right? Right, after that, integrating both sides. Okay? From this equation here, we just put integration sign for both sides, right? Then we integrate left hand side and right hand side. When we integrate 1/p dp, we get ln p plus c, okay? But we just put plus c on one side only, okay? We use this formula. When we integrate 1/x dx, the answer equals to ln x plus c. So when we integrate 1/p dp, the answer equals to ln p plus c, right? And then to integrate constant k dt, we can use this formula. Let's say we want to integrate constant 2 dx. Okay? The answer equals to 2x because we integrate with respect to x. And then we put plus c at the back. Okay? Now we want to integrate constant k dt. So the answer equals to kt plus c. Alright? Alright, after that, we need to write population P as a subject. So, we need to move ln to right hand side. Okay, when we move ln to right hand side, so we get P as a subject equals to, we get base E here. Okay, we get index base E. And then to the power of KT plus C. Okay, after we move ln to right hand side. Okay, so we get this. Alright. Now we have P as a subject, right? And from here, we can write e to the power of kt plus c equals to e to the power of kt times e to the power of c. Okay? We use properties of indices from a to the power of m times a to the power of n. It equals to a to the power of m plus n. So from here, we compare with this formula, so we get this, right? And after that, we can write P equals to C e to the power of kt, because e to the power of c equals to constant. E is an Euler number, which is equals to 2.718 something. So this is a constant. Constant to the power of constant equals to constant. So we can write e to the power of c equals to constant c. Okay. So now we have P equals to CE to the power of KT, right? Then we can name as equation 1, right? From the previous slide, we extract all the information in terms of T and P, and then we get P equals to CE to the power of KT, and we name as equation 1, okay? And from the first information here, we can substitute into equation 1 to find C. And from the second information, we can find K, right? So to find C, we substitute T equals to 0 and P equals to P naught into equation 1. Okay, so from equation 1, P equals to CE to the power of KT. After we substitute P equals to P naught and T equals to 0 here, okay, 0 times K equals to 0, e to the power of 0 equals to 1. Okay, so C times 1 equals to C, so we get C equals to P naught. Okay, after that, we substitute into equation 1. Okay, so we get this. P equals to P naught e to the power of kt. We substitute C equals to P naught into C in equation 1 here. So we get P equals to P naught e to the power of kt. Alright. After that, we name as equation 2. Alright. Then from here, to find K, substitute T equals to 12 days, P equals to 2 over 3 P naught into the latest equation, into equation 2. Okay, so from equation 2, P equals to P naught e to the power of kt. We replace T equals to 12 days, and we replace P equals to 2 over 3 P naught. Okay, and after that, we can move P naught to left hand side, so we get 2 over 3 P naught over P naught, so we can simplify P naught here. So we can write e to the power of 12k equals to 2 over 3. No more P naught because we simplify P naught for both sides here. Alright. Now we want to find k. Okay, so we need to move e to right hand side. When we move e to right hand side, so we get 12k equals to ln 2 over 3, right? And then to find k, we divide ln 2 over 3 by 12 here. So we get k equals to negative 0.03378 up to 5 decimal places, right? Right, from here we get k negative value because the radioactive decay here. Alright. Right, after we find the value of k, we substitute into equation 2. So we get this. Right? We substitute k equals to negative 0.3378 into k in equation 2. So we get P equals to P naught e to the power of negative 0.03378 T. Right? Then we name as equation 3. Okay, equation 1, 2, and 3 actually are the same equation. Okay, but equation 1, we still write in terms of C and K. Equation 2, we substitute the value of C. And equation 3, we substitute the value of C and K. Right? From the previous slide, we get this. P equals to P naught e to the power of negative 0.03378t, and we name as equation 3. This is an expression for the population at any time t, right? After that, we can substitute the last information into equation 3 here, okay? Alright, the question is determine its half-life. So to find half-life, we substitute P equals to half P naught into equation 3 here. From equation 3 here, we replace P equals to half P naught. Okay, then we can simplify P naught on both sides here. So we get e to the power of negative 0.03378t equals to half. Okay, we get back half because we solve half-life here, right? And after that, now we want to find half-life. Half-life means find t when p equals to half p naught. So now we need to write t as a subject. So we move e to right-hand side. Okay? So after we move e to right-hand side, so we get negative 0.03378t equals to ln 0.5. Okay? 0.5 here means half. Okay? So after we move e to right hand side, we get ln here. Right? Then we can write t as a subject. So we move negative 0.03378 to right hand side. So we get this. Okay? Alright. This is the half-life. Okay? And from half-life formula, it is equals to ln half. Why half? From ln 0.5 here because half-life here. Okay, half p naught. Okay, so half-life equals to ln half or ln 0.5 over k. This is the value of k actually. Right? Right, then we solve using calculator, so we get t equals to 20.5. Then we must put a suitable unit. Okay, from the given question, okay, we have the period here in days. So we can write days here, right? Then we can write the half-life of Einsteinium 253 is 20.5 days. Alright? This is the final answer. Okay? Determine its half-life. Alright? Coming up next, more examples for radioactive decay and the applications of separable differential equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.